Hello viewers, welcome back to my YouTube channel. So in this particular problem statement, we are going to draw the projection of an isosceles triangular plane. Isosceles means its two sides will be equal, right? With base of 100 mm and altitude or height of 150 mm. Okay, whereas its base is in HP. Base is in HP means and surface makes an angle of 45 degrees to HP means its true shape will be in the HP, right? And the true length will be on XY as base in HP is given. Okay, so now we are going to draw the positions for the same. Select a reference line. Okay, so I'm selecting this as a reference line XY. Okay, giving the naming text. Okay, starting point is this one. Okay, point 2, rotation angle is 0. So this is my X and Y reference plane. Okay, this is VP. In VP I'm always drawing front view, right? In the HP I'm always drawing top view, right? So these things you have to repeat every time. Now I'm going to draw one triangle of base 100 mm and height is 150 mm. So I'm going to select one line basically, okay, of 100 mm. Okay, so this is one AutoCAD unit basically, that is 100 mm, right? And center of this is basically, you can mark for your reference if you want to mark it out. Okay, so this is the center of this particular line of the 100 mm side. Okay, from this particular point you need to draw one horizontal projections, okay, of how much dimensions? 150 mm. Okay, so 1.50 AutoCAD units. Okay, then press escape. So this you got another point. Okay, now join this particular point and this particular line. Okay, again select a line, join this particular end of the line to this particular point. Okay, and then press escape. Okay, so this is basically an isosceles triangle of base 100 mm and height is 150 mm. So you can check the dimensions again. Okay, so this is 100 mm base, right? And you can check the dimensions from here. Okay, this particular line, this is 150 mm. Okay, so immediately convert this particular dimensions into cyan color, press escape. Now start giving the names. Okay, so this is basically coming in the white color. Okay, sorry, in the cyan colors. Okay, so what you can do, you can control J it. Okay, and this particular line you need to convert it into red color first. Okay, for your understanding. Okay, then convert this particular to cyan color. Okay, and finally once you are able to convert it to cyan color, convert this line into white color. Now you can able to see, right? So this will come from the practice. Okay, because our true shape, true length and all the inclination should be in white color, rest of the dimensions will be in cyan and the projected lines will be in the cyan colors. Okay, let's escape. Okay, now give the text. Okay, start any point here. Okay, give the naming point 1 height and rotation angle is 0. Okay, so this is my point A, this is my point B, and this is my C. So this is ABC, an isosceles triangle of base 100 mm and height is 150 mm. Now in the problem statement it is given that its base in HP. Base in HP means basically my true length will be on the XY line. So what I'm going to do, I'm going to press right escape button. I'm going to draw vertical projectors from this, select ortho here. From this particular point I'm going to draw vertical projectors. From this particular point I'm going to draw another vertical projectors. Okay, now what you need to select, you need to select the point here. Okay, so this is my first point, this is my second point. Okay, and immediately convert this particular projector into cyan, escape. Okay, so now give the naming, text, select anything on the screen, point to 1 and rotation angle is 0. So this is my basically A dash, sorry, A dash, B dash, and this is my C dash, and this is basically my true length. Okay, and let us check the dimensions of this true length. Select a line, okay, this particular point with 150 AutoCAD, okay, convert it into cyan colors. Now I need to incline this true length by how much angle it is given? 45 degrees. Okay, so what I'm going to do, I'm selecting any point on this reference line. So let us say here, from this I'm going to select a line which is basically of so it is coming, click on the ortho, basically of 1.5 AutoCAD unit, press tab, and the rotation angle is 45 degrees. So press escape. So now this is my line of 1 mm dimensions, and inclination is given 45. So you can basically select the point here. Okay, now give the dimension, select align. Okay, this particular point, this is 150 mm, go to dimensions, select angular dimensions, this particular line, you can see this 45. So immediately convert this dimensions into cyan color. Okay, now you can give the naming. Okay, the text, select any point here, point to 1, and rotation angle is 0. Okay, so this is my A dash, B dash, and this particular point is my C dash. Okay, and this is my true length inclination. Okay, yes or no, right? Select and set, and then draw vertical projectors from this particular point. So you might have observed all the steps are similar in the case of projection of planes. Okay, so we are not going on the third step. Third step is basically auxiliary inclined plane method. Okay, so for your syllabus we are actually coming towards the two steps. Okay, now from this particular point I'm going to draw one projector. From this particular point I'm going to draw another projector, and from this particular point C I'm going to draw another projector. Okay, now mark the point here. Okay, so convert these projector lines into cyan color first. Okay, so I'm converting, I'm selecting this, so unsnap, click on unsnap. Okay, converting into cyan color, press escape. Now mark the point. Okay, so this is A and B vertical projections. So this is my point A, this is my point B, and this is C, this is C, this is my point C. Immediately join these 3 points with a straight line. Okay, so click on the ortho. Okay, and then join this particular line, this, and this is I basically top, right? Then give the command retext, select any point here, point to 1, rotation angle is 0. So this is my top view, this particular point is A1, this is my B1, and this is my C1. So in the top view, the triangular isosceles triangle will look like this. And this is basically the solution for this particular kind of problem statement. So I hope you like this video. If you like this video, please like, share, and subscribe.